Let's look at speed, distance, time. We are going through 17 exam questions. Here is the first one from June 2018, and it's paper 2, so we are allowed to use a calculator. Press pause and have a go. When you're ready, press play. Emily drives 186 miles in 3 hours. What is her average speed? So we've got 186 in 3 hours. What is her average speed? Press pause and have a go. Now, the first thing we have to remember is that we have to memorize the formula. Speed equals distance divided by time, or any other combination that you may have remembered, and then we can put this in a triangle. 186 miles is our distance, so we can put 186 there. 3 hours is our time. Speed, distance, time. And so our speed equals to distance divided by time, which is equal to 186 divided by 3. Get our calculator out. 186 divided by 3 gives us 62. So our answer is 62 miles per hour. Okay, so we've got Sarah drives at an average speed of 58 miles per hour for 4 hours. How many miles does Sarah drive? So again, press pause. When you're ready, press play. We've got 58 miles per hour for 4 hours. And we need to see how many miles does Sarah drive. So how many miles does Sarah drive? How many? That tells me distance. And another thing, here's a little hint for you. If you don't remember the formula, speed, our average speed is that. So we are saying speed equals miles per hour. So that's miles per hour. If you forget the formula, miles is distance and hour is time. So miles per hour. So if we look at our distance, we've got it here from part A. Distance is at the top. Speed and time is at the bottom. So distance equals speed times time. So my speed is 58. And I'm multiplying by my time, which is 4 hours. Put that into the calculator. 58 times by 4. That gives me 232. 232. Okay, well done if you got that right. Let's go to the next question. Well, before we do that, here is an analysis of exam papers that I've looked at, and you can see that in Foundation, it comes in paper 1, as well as paper 2 and paper 3. So it comes in all papers. So this is a calculator and a non-calculator topic. And I looked at 12 sets of exam papers and there were 17 questions. So you can see how popular this topic is. This question is from November 2023, paper 2. So we are allowed to use a calculator. We're going to skip the first part because that's not relevant for us. And we are going to go to the next part, which is here. Press pause and have a go. When you are ready, press play for the answer. A car travels at an average speed of 37 miles per hour for 3 hours. Work out the distance that the car travels in the 3 hours. So again, press pause, have a go. If you are ready or stuck, then you can press play. I'm going to go through this. So a car travels at an average speed. So we've got speed is 37 miles per hour for 3 hours. Work out the distance that the car travels in the 3 hours. I don't need to highlight 3 hours again, but I have that there. So similar to before, we have to memorize our formula. So you need to remember speed, distance. And again, here, it's given us a hint. So if we did forget the formula, we can use that. Speed is miles per hour, which is miles is distance, hour is time. So I've got my formula. I can turn this into a triangle. Speed, distance, time. Okay, so now I've got my information. Now I can put this in. So I'm going to be working out distance. So distance is going to be speed times time. So my speed is 37 miles and my time is 3 hours. Put that in a calculator. 37 times by 3 gives me 111. So that is my miles. Let's go to the next question. This is question 3 of 17. And this one is from June 2023, paper 2. Press pause and have a go. Okay, if I read information, Paolo drives at an average speed of 56 kilometers per hour for 1 hour 45 minutes. Work out the distance Paolo drives. So press pause. When you're ready, press play. So we've got speed, 56 kilometers per hour for 1 hour 45 minutes. Work out the distance that Paolo drives. So what I'm noticing here for this question is I've got 56 kilometers per hour and I've got 1 hour 45 minutes. So here, my units are different. So I need to be careful about that. I need to be careful on how I do this. So again, memorize the formula. Speed equals 56 kilometers per hour. If you forget, that's distance divided by time. So step 1, I have to remember my formula, speed, distance, time. I'm working out my distance. So my distance equals speed times time. Now my speed is 56 and my time is 1 hour 45 minutes. Now they are in different units. How do I make them the same? So what I'm going to do is I'm going to keep 1 hour as it is plus 45. How many minutes are there in an hour? 1 hour equals to 60 minutes. So I'm going to be dividing this by 60. Okay, and then I'm just going to put that into my calculator. 56 times by 1 plus 45 divided by 60. Okay, I can just do that. Just going to separate this here just to rewrite it in a second, in case you're a bit worried about how do you put this into your calculator. So fix 56 times by bracket 1 plus brackets 45 divided by 60. Close bracket, 2 brackets there, and that gives me 98. And if this looks really complicated for you, we can just write it out as speed times time, 56 times by, you can do 45 divided by 60. 45 divided by 60, that is 0.75, and then just add the 1. So that gives you 1.75. You can also multiply them and it will still give you the same answer, times by 56. There you are. Okay, so that's our third question. Let's carry on. Okay, here's a quote to keep you inspired. It always seems impossible until it's done. So if you're learning about speed, distance, time, you're thinking, I'm confused, I'm never going to get this. It seems impossible, but keep practicing and suddenly you'll see it's possible. Now, hopefully my video will help you master speed, distance, time. So keep going. Let's go to the next question. Okay, so this question is from November 2018, paper 3. Pause and have a go. So let me read the information. Lara is a skier. She completed a ski race in 1 minute 54 seconds. The race was 475 meters in length. Lara assumes that her average speed is the same for each race. Using this assumption, work out how long Lara should take to complete a 700-meter race. Give your answer in minutes and seconds. So have a think about how we do this question. There's lots of information there. Press pause and have a go. When you're ready, you go through the answer. Okay, if I highlight key information, I've got Lara is a skier. She completed a race in 1 minute and 54 seconds. And you've got the race was 475 minutes in length. Lara assumes that her average speed is the same for each race. So I think that's important to highlight. Using this assumption, work out how long Lara should take to complete 700-meter race. Give your answer in minutes and seconds. So first of all, let's understand what's going on in this. So Lara is a skier. She is doing a race, and in the race, it's 1 minute 54 seconds. So that's my time. And the race is 475 meters in length. So that's my distance. So from here, I can work out the speed. Lara assumes her average speed is the same for each race. So she does a second race. Using this assumption, work out how long Lara should take to complete a 700-meter race. So she's doing a longer race because this is now 700 meters. This is our distance. And we have to make sure our answer is in minutes and seconds. So there's a lot going on in this question. So I'm going to take it one step at a time. So just like before, we need to memorize our formula. Speed equals distance divided by time. And then using that, we can use our triangle, speed, distance, time. Okay, so now I can see that for this part, I'm going to be working out the speed. So the speed is going to be, if I cover the speed here, speed is distance divided by time. So speed equals distance divided by time. So my distance is 475 divided by, I've got 1 minute and 54 seconds. So my units are not the same here. So I need to keep them the same. So I'm going to have 1 minute and 54 seconds. How many seconds make a minute? 54 divided by 60. So it's a bit like the last question that we did. So I'm going to keep it like that. I'm going to get my calculator. And so I'm going to do 475 divided by bracket 1 plus bracket 54 divided by 60, close bracket. That gives me my answer, which is 250. Okay, so that's my speed, 250. Now, Lara assumes that her average speed is the same for each race. So we keep the speed the same. Using this assumption, work out how long is time. So if I cover my time here, it's distance divided by speed. So time equals distance divided by speed. So my distance now is 700 meters. divided by my speed is 250. That gives me 700 divided by 250. That gives me 2.8. Now this is in terms of minutes. So I have to be careful because my question says minutes and seconds. So what I can do is if I look at my calculator, I've got this speech mark button here. So if I press that, that tells me it's 2 minutes and 48 seconds. Okay, so that's my answer, 2 minutes and 48 seconds. And so I can write that out in my answer here. 2 minutes and 48 seconds. Okay. Now, if I look at part B, part B says, Lara's average speed actually increases the further she goes. How does this affect your answer to part A? So I'm going to press pause and have a go. When you're ready, press play again. So I'm going to highlight Lara's speed, average speed actually increases. How does this affect our answer? So our answer is here 2 minutes and 48 seconds. So if the speed increases, then I'm going faster. So if I'm going somewhere faster, it should take me less time. Then time goes down. Okay, in other words, I don't need to write if speed increases, then time goes down. That's it. That's enough. Okay, let's go to the next question. All right, the next question. This is our 5th of 17 questions. So November 2019, paper 3. So we are allowed to use a calculator. We're going to skip this question here, 26, and we're going to go straight to 27. Press pause and have a go. When you are ready, you can press play for the answer. Okay, let me read the information. Nimer was driving to a hotel. He looked at his sat-nav at 13:30. So time, 13:30. Distance to destination is 65 miles. Nimer arrived at the hotel at 14:48. Work out the average speed of the car from 13:30 to 14:48. You must show all your working. So if we look at this, let's highlight key information again. Nimer was driving to a hotel. We don't really need the first sentence. He looked at his sat-nav at 13:30. We don't really need that because it's highlighted here. The distance is 65. He arrived at his hotel at 14:48. Work out the average speed of the car. So let's see how we would do this. So I'm going to draw a time. So first of all, we need to remember our formula. So speed equals distance divided by time. Remember that. And then we can turn this into our pyramid. Speed, distance, time. So we've got that. Our distance is 65. Okay, work out the average speed. So speed is going to be distance divided by time. So you can see from here, it's going to be 65 divided by, I need to work out my time. So how do I work out my time? So I'm starting from 13:30, and I'm ending at 14:48. Okay, so I need to work out the time here. I'm using a timeline. So if I add an hour, 14:30, that's 1 hour. And then I'm going from 30 to 48. So I'm adding 30 plus 10 is 40, add another 8, so that's 18 minutes. Okay, and if I think about conversions, hours and minutes, I need to make them the same. It's 18 minutes out of 60 minutes in an hour. So my division becomes 1 hour plus 18 divided by 60. And that is it. So I just need to put that into my calculator. So I've got 65 divided by bracket 1 plus bracket 18 divided by 60. Close bracket. And then when I press enter, I've got 50. 50 is my answer. And so my answer is 50 miles per hour. Okay, so that's our 5th question out of 17. And if you are new to the channel, remember to subscribe. You can see that we are going through a topic. They start off easy and they get harder and harder. So if you are enjoying this, I do appreciate your time. And I do appreciate you tuning in, and hopefully this will help you with your revision. Here is the next question. This is question 6 of 17. We're now going into paper 1, which is a non-calculator paper. So we're going to be doing this question without using a calculator. And this is from May 2019. So here is the question. Press pause and have a go. So it says, Ruth left her home at 9 a.m. and walked to the library. She got to the library at 10:30 a.m. Ruth walked at a speed of 4 miles per hour. Work out the distance Ruth walked. If I highlight, look at my information, I've got Ruth left her home at 9 a.m. and walked to the library. She got to the library at 10:30 a.m. Ruth walked at a speed of 4 miles per hour. Work out the distance that Ruth walked. So just like before, I need to write out my formula. Speed equals distance divided by time. Turn that into a pyramid. Speed, distance, time. So my distance, cover distance, B is speed times time. Distance equals speed times time. So I now need to get my information. The information that I have is speed is 4 miles an hour. I need to work out my time. So Ruth left her home at, and similarly to the last question, I'm going to draw a timeline. She left her home at 9 a.m. and walked to the library. She got to the library at 10:30 a.m. So 10:30 a.m. Okay, so that's my 10:30 a.m. So what is that time? So in the middle, I've got 10 a.m. So that's going to be 1 hour. And this is 30 minutes. Okay, I've got hour and time. I need to make them the same. So this is half an hour or 0.5. Okay, 0.5 hours. So altogether, this is 1.5 hours. So times by 1.5 hour. So how do I work this out? I can split this up without a calculator. So I can do 4 times 1, which is 4. What's half of 4? Half of 4 equals to 2. So I can just add these two together. 4 plus 2 gives me 6. So my distance is 6 miles. It's back to write D there. Distance is 6 miles. Okay, and so that's the answer to my question. All right, well done if you got 6. Okay, let's go to the next question. This is now question number 7 of 17. Let me just get that focused right. Oops. Okay, focus is a bit better now. All right, press pause and have a go for that question. Otherwise, I'm going to go through it again. So let's go through this information. What does it say? Again, paper 1, so it's a non-calculator paper, November 2022. Jeremy drives from London to Swindon at an average speed of 54 miles per hour. She drives for 1.5 hours. Work out the distance from London to Swindon. Okay, so we've got London to Swindon. Average speed is 54 miles per hour. And again, we'll come back to that. She drives for 1.5 hours. Work out the distance. And again, if you forget the formula, here's a hint for us. Miles per hour. Speed equals miles per hour. Miles is in distance. Miles is distance. Hour is time. Turn this into our pyramid. Speed, distance, time. Okay, so we've got speed is 54. Speed is 54. She drives 1.5 hours. So that's our time. 1.5. Okay. Work out the distance. So distance equals speed times time. And so I can just multiply them. 54 times by 1.5. Now this is non-calculator. How do I do this? Similar to before, 54 times 1 is just 54. What's half of 54? Half of 54. What's half of 50 is 25. Half of 4 is 2. Add them together, so that's 27. So half of 54 is 27. So I just add these together. 54 and 27. 7 plus 4, 7, 8, 9, 10, 11. 1 plus 5 is 6. Add the 2, 7, 8. So my answer is 81. 81 miles. All right, well done if you got that. Part B, we're going to ignore again because it's not really linked to speed, distance, time. It's another topic, which is for another time. Okay, this is now our 8th question of 17. And again, this is paper 1 of May 2022. Press pause and have a go. And again, when you're ready, you can press play for the answer. Okay, so let's go through the information again. Let me just make sure you can see the screen. All right, so we've got here, Savio leaves his home at 7:30 to drive to work. He drives a distance of 50 miles. Savio thinks he drives at an average speed of 40 miles per hour. If Savio is correct, at what time will he arrive at work? So let's see what we need to do here. Let's highlight Savio leaves his home at 7:30. He drives a distance of 50 miles an hour. Savio thinks he drives an average speed of 40 miles per hour. What time will he arrive at work? So again, first things first is we need to work out remember our formula. So again, speed is miles per hour, distance divided by time. Speed equals distance divided by time. Speed equals distance divided by time. Now you might be thinking, why am I writing it every single time? Make it a habit. If you have this as a habit, then when it comes to the exam, you're just going to write it down and you can get those method marks. All right, so now we need to work out the next part, which is time. So we need to cover time, t. So that's distance divided by speed. So time equals distance divided by speed. So I can see from here, my distance is 50 and my speed is 40. So it's going to be 50 divided by 40. Okay, so how do I do this? So if I simplify, I can divide by 10. Divide by 10. That gives me 5 out of 4. It's a non-calculator paper, so I can't really use a calculator. How many times does 4 go into 5? It goes in once. What's my remainder? 1 out of 4. 1 out of 4 is a quarter. So that's a quarter of an hour. That's 1 hour. If 1 hour equals 60 minutes, what's a quarter of an hour? So I'm dividing by 4. A quarter of an hour is going to be 15 minutes. So 60 divided by 4. So that's 1 hour, 15 minutes. And so I go back to my time. I start at 7:30. 7:30. I'm going to add 1 hour. 1 hour. So that makes it 8:30. And I'm going to add 15 minutes. So that makes it 8:45. And so my final answer is going to be 8:45. Okay, let's go to part B. In fact, Savio's average speed was greater than 40 miles per hour. How does this affect your answer to part A? Okay, press pause and have a go. So Savio's average speed was greater than 40 miles. So how does this affect our answer? So the speed has gone up. Speed is higher, is greater. That means I'm moving faster. If I go somewhere faster, it takes me less time. It takes less time. Okay, think about you going to school. If you're walking to school, how long would it take you? Let's say it takes you 50 minutes. And then you run to school, you're going faster. It will take you less than 50 minutes. So our time is less. It takes less time. So he'll get there before 8:45. In your answer, you need to make it really clear. So it needs to be unambiguous. That's the wording that the mark scheme uses. So well done if you got that right. Let's go to the next question. The next question is from paper 3. Okay, so let me read the information. Riley traveled by car and by aeroplane. He traveled 143 miles by car at an average speed of 55 miles per hour. Riley then traveled for 5 hours and 20 minutes by aeroplane. Work out in hours and minutes Riley's total traveling time. So let me highlight the key information. So Riley traveled by car and aeroplane. He traveled 143 miles by car at an average speed of 55 miles per hour. Riley then traveled for 5 hours and 20 minutes by plane. Work out in hours and minutes the total traveling time. So if you think about this, what's going on? On this occasion, he's using 2 forms of transport. So this question is different because we've got 2 things happening here. So in the past, we had 1 thing happening. On this occasion, it's 2 things. So what we need to do is create a table. If we create a table, that will make it easier for us. So I'm going to have car. So we're going to have car. We're going to have plane, aeroplane. We're going to have speed, distance, and then time. And that will reduce our difficulty for this question. If you're doing this without a table, it will be much, much harder. And also we want a total, so we need to add another column for total. So that is what we need to do. So by creating a table, the difficulty for this becomes much easier. And just like before, first of all, we need to work out the formula. Remember the formula. So speed is miles per hour, distance divided by time. So I can now create my formula. Speed, distance, time, formula pyramid. And so now I can start filling in for the information. He traveled 143 miles by car. So that's distance. So car and distance is 143. Speed is 55 miles per hour. So speed is 55 miles per hour. Right, he then traveled for 5 hours and 20 minutes. So you can see there's different units here. 5 hours by aeroplane. So that is time. Aeroplane and time is 5 hours and 20 minutes. Work out in hours and minutes Riley's total traveling time. So time, so if I cover time, my formula is distance divided by speed. So time equals distance divided by speed. My distance is 143 divided by speed is 55. It's a calculator paper, so put it into the calculator. 143 divided by 55 gives me 2.6. So this goes in here. Now, what I need to be careful of here is that this is in hours and minutes. I need to keep them the same. So I'm going to have 5 plus 20 divided by 60 minutes in an hour. So I need to do that. So my total time becomes 2.6 plus 5 plus 20 divided by 60. That is going to be my answer, 7.93. Now this is as a decimal. Remember, I need to change it to minutes, in terms of minutes. So I can just press this button here, the one that is got the speech marks, that converts it for me. 7 hours and 56 minutes. 7 hours, 56 minutes. And if you don't know how to do that, what we can do is we take it back to the decimal. We can take away the 7. So this is the decimal part. The decimal part is that we just multiply it by 60. That's 56 minutes. So that's how we convert it to 7 hours and 56 minutes. Here is the next one. So again, this is paper 3. So this is a calculator paper from June 2020. This is our 10th question of 17. So press pause. When you are ready, you can press play for the answer. I'll read the information. Information is Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs. Work out Amy's average speed. Give your answer in miles per hour. Okay, so you can see it's similar to the last question. We've got things going on. So let's highlight key information. So Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs. Work out Amy's speed. Okay, give your answer in miles per hour. So just like the previous question, we're going to turn this into a table. So we've got Jessica running, and she's got 2 parts here, Jessica. And then we're going to have a total, because it's a total distance. And then we've got Amy running as well. And we have speed, distance, and time. Okay, this table helps me put everything in the right place. So Jessica runs for 15 minutes, and now 15 minutes. So she runs, that's my time, 15 minutes. Now, I need to turn it in terms of an hour, so I'm going to divide it by 60. So that's now as an hour. At an average speed of 6, so 6 miles an hour. She then runs for 40 minutes, so that's time again. 40, again, out of 60 minutes. Can do that. At an average speed of 9 miles an hour. It takes Amy 45 minutes, so Amy time is now 45 minutes out of 60, because 60 minutes in an hour. To run the same total distance, we need the total distance here. And then we need to work out the speed here. So these are the two boxes that we need to get to. All right, so you can see clearly here, I need to work out the distance. If I work out the distance here and here, that will give me the total. And if I can work out the total, that will tell me how to work out the speed. So again, speed equals distance divided by time. Turn that into a triangle. Speed, distance, time. Okay, and so for this part here, I've got my speed is 6. My time in terms of an hour is 15 out of 60. That's my distance. So distance equals speed times time. 6 times 15 divided by 60. 6 times bracket 15 divided by 60 gives me 1.5 miles. Put that in here. And the same thing for the second part. My speed is 9. My time is 40 out of 60. So my distance equals 9 times 40 out of 60. 9 times 40 divided by 60. That gives me 6. So my total is these two added together. So total distance equals 6 plus 1.5, which is 7.5. So now I've got 7.5 here. I can put 7.5 there. So now I can work out the speed for Amy. So I can turn my formula triangle. My distance is 7.5 and my time is 45 minutes, 45 out of 60. So my speed equals distance divided by time, 7.5 divided by 45 minutes out of 60 minutes in an hour. So my speed equals 7.5 divided by bracket 45 divided by 60, close bracket. Gives me 10. So my answer is 10 miles per hour. So a lot of work for that question. And you can see this is both a higher and a foundation question. So this is getting harder. And this is part of the masterclass. The questions are only going to get harder. They're not going to get any easier. So we started off, if you think about what we started with, question 1 to where we are at now, it's a huge difference. Okay, let's look at the next question now. Question 11 of 17. This is from June 2017, paper 2, so we are allowed a calculator again. Ollie drove 56 kilometers from Liverpool to Manchester. He then drove 61 kilometers from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometers per hour. Ollie took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for his total drive from Liverpool to Sheffield. Okay, press pause and have a go. When you are ready, you can press play for the answer. Work out his average speed for the total drive from Liverpool to Sheffield. So again, because there's lots going on, create a grid. So we've got Liverpool to Manchester, L to M. And we've got Manchester to Sheffield. And then we have the total. The total is Liverpool to Sheffield. Okay, that's our total. So we create a grid. Speed, distance, time. Okay, and that will make it the problem much easier to work out, because now we just have to fill in this grid. All right, so Ollie drove 56 kilometers. That's distance, so that's 56 here. And again, I'm going to write units because they will come in handy later. He then drove 61 from Manchester to Sheffield, so this is 61 kilometers. Ollie's average speed from Liverpool to Manchester was 70. L to M was 70, and that's speed. 70 kilometers per hour. Ollie took 75 minutes to drive from Manchester to Sheffield, 75 minutes. And I need to turn this into hours. So that is going to be 75 divided by 60. Okay, because there are 60 minutes in an hour. All right, so I've got that. Work out Ollie's average speed for his total drive. So we want to work out the total speed. So in order to work that out, I need to work these two out. And again, if we look at information here, speed is kilometers per hour. Kilometers is distance divided by time. So again, step 1 is remembering our formula. Speed equals distance divided by time. So always start with the formula, then go into your pyramid. So now I'm working out time. So time is going to be cover time, distance divided by speed. So time is going to be, my distance is 56 divided by my speed, which is 70. So my time equals 56 divided by 70, 0.8. Okay, so that's in hours, that's in minutes, but this is in hours. Okay, so I can work out my total time. I can do that plus, or 0.8 plus 75 divided by 60. 75 divided by 60. That's 2.05. Okay, now I need this distance here. So I actually don't need that at all. I just need this. So I can just add these two together. 56 plus 61 gives me 117. And so if I need to work out my speed, cover speed, I've got my formula here. Speed equals distance divided by time. My distance is 117 divided by my time is 2.05. It's in terms of hours. Put that into my calculator. 117 divided by 2.05. Change it to a decimal. 57.07317. So usually 3 significant figures or 1 decimal place. So this 7 rounds up. So my speed is 57.1 kilometers per hour. Let's go to part B now. Part B is a bit more information here. All right, press pause and have a go. When you are ready, you can press play for the answer. Okay, so let me read the information. Janie drove from Barnsley to York. Janie's average speed from Barnsley to Leeds was 80 kilometers per hour. Her average speed from Leeds to York was 60 kilometers per hour. Janie says that the average speed from Barnsley to York can be found by working out the mean of 80 kilometers per hour and 60 kilometers per hour. If Janie is correct, what does this tell you about the 2 parts of Janie's journey? So Janie drove from Barnsley to York. Her average speed from Barnsley to Leeds is 80 kilometers an hour. Her average speed from Leeds to York was 60 kilometers per hour. Janie says that the average speed from Barnsley to York can be found by working out the mean of 80 and 60. If Janie is correct, what does this tell you about the 2 parts? So from Barnsley to Leeds, it's 80 kilometers an hour. That means in 1 hour, it's 80 kilometers. From Leeds to York was 60 kilometers per hour. So in 1 hour, it's 60 kilometers. And we're saying that the mean of 60 and 80. So what we are assuming here is they have the same time. So we can say time is the same. Because we're adding them together and dividing by 2. That's what mean means. So that's a very tricky one. 1 mark for that in the exam, thinking about this and hopefully trying to make those connections. 1 hour, 80 kilometers and 60 kilometers, add them together, divide by 2 is the mean. And so therefore time is the same. So I hope that one, you got that right as well. Let's go to our next question. This is paper 3, so again, calculator paper from 2020. Andy cycles a distance of 30 kilometers at an average speed of 24 kilometers per hour. He then runs a distance of 12 kilometers at an average speed of 8 kilometers per hour. Work out the total time Andy takes. Give your answer in hours and minutes. So press pause, have a go. I will go through the answer. Let me grab my highlighter. Okay, so Andy cycles a distance of 30 kilometers at an average speed of 24 kilometers per hour. He then runs a distance of 12 kilometers. Again, the average speed is 8. Work out the total time. Give your answer in hours and minutes. And hopefully you are feeling much more confident with this question. You can see this is different to question 1 and 2 that we started with. And you can see we've got 2 parts. He's cycling and he's running. So we've got 2 things going on here, cycling and running. So what we can do is we can turn this into a table, cycling and running. And then we also have total time. So we're going to have speed, distance, time as well. Speed, distance, time. Andy cycles a distance of 30 kilometers. So distance is 30. Keep the units. Average speed is 24 kilometers per hour. He runs at a distance of 12 kilometers. So running distance is 12 kilometers. At an average speed of 8 kilometers per hour. So speed equals to 8 kilometers per hour. Nothing to worry about. The units are all aligned. Okay, so we want to work out the total time. So we need the time here and the time here, and then we just add it to work out the total time. Speed equals distance divided by time. And so here we're working out time. Time equals distance divided by speed. So we're going to have 30 divided by 24. That gives me 30 divided by 24. That gives me 1.25. And that's in terms of hours, which is good. My units are fine. Same thing again, time equals distance divided by speed. Distance is 12 divided by 8. 12 divided by 8 gives me 1.5. 1.5. And so the total time is going to be adding them together. 1.25 plus 1.5. That gives me 2.75. This is in terms of hours. And again, press the speech mark button here. That converts it for me. 2 hours and 45 minutes. And in case you don't have that, how would you do it without this function if you don't know how to work it out? Take away 2. I want the unit part. Take away 2. That's the decimal part of hours. How many minutes in an hour? 60. So we times it by 60. We get 45. So that's my final answer. 2 hours and 45 minutes. Okay, so the next question now for the masterclass. This is our 13th question of 17. We're towards the end now. This is from paper 1, non-calculator, November 2018. We're going to skip this part because it's not relevant, but it is on the page. And we have to do this question now. All right, so the question says, a plane travels at a speed of 213 miles per hour. Work out an estimate for the number of seconds the plane takes to travel 1 mile. Press pause and have a go. When you are ready, you can press play for the answer. All right, let's highlight key information. A plane travels at a speed of 213 miles per hour. Work out an estimate for the number of seconds the plane takes to travel 1 mile. So that's our information. So the key things here that I'm spotting are, we've got speed, but we've got estimate. So we're going to be using estimate. And also you can notice we've got miles per hour and seconds. So that's the tricky thing here. So let's look at, first of all, speed of 213 miles per hour. So in 1 hour, you're traveling 213 miles in 1 hour. Okay? Now, we can change the hours into seconds. How many seconds are there in an hour? So 1 hour equals to 60 minutes. Okay? And now, so we've got that, 60 minutes. But that doesn't help us. We need to take this into 60 seconds. 1 minute is 60 seconds. Times that by 60. 6 times 6 is 36. And I've got 2 zeros. So I've got 213 miles in 3600 seconds. So the next thing, if I think about it, is I'm estimating, so I can round this down. So this can become 200 miles. Now I can remove the zeros, so I can divide by 100. So this is 2 miles in 36 seconds, which means 1 mile is going to be half of that, so divide by 2. Half of 30 is 15, half of 6 is 3, 3 plus 15 is 18. So 18 seconds is my answer. Now you can work this out many ways. The mark scheme does give us a range of 16 to 20 seconds. So that's possible. So well done if you got that. Let's look at the next part B. It says, is your answer to part A an underestimate or an overestimate? Give a reason for your answer. So press pause and have a go. And when you're ready, press play for the answer. So is your answer to part A an underestimate? So if I look at my working out, I rounded down here 200 miles, 213 became 200. So I made it lower. So here it's saying 1 mile is in 18 seconds. So because I made this lower, in reality, it's more than 1 mile. It's slightly more than 1 mile. Answer, 1 mile is not going to be in 18 seconds. It's going to be less than 18 seconds. So in reality, 1 mile is less than 18 seconds. So my answer, okay, let's say it was 17, for example, just for argument's sake. So 18 is more than 17, that makes sense. In reality, 1 mile is less. So my answer is an overestimate. My answer is an overestimate. Okay, so I'm saying it's 18 seconds, but it's actually less. So imagine it took me 17 or 10 seconds. So 18 is more than whatever it is. So therefore, my answer is an overestimate. So I hope that makes sense. Here is the next one. We're nearing the end now. Question 14 of 17. This is from May 2018. And again, paper 1. So we are not allowed to use a calculator. Press pause and have a go. A cycle race across America is 3,069.25 miles in length. Juan knows his average speed for his previous races is 15.12 miles per hour. For the next race across America, he will cycle for 8 hours per day. Estimate how many days Juan will take to complete the race. Okay, so that is the information. Press pause. When you are ready, press play for the answer. So a cycle race across America is 3,000 miles in length. Juan knows his average speed for his previous races is 15 miles per hour. For the next race across America, he will cycle for 8 hours per day. Estimate how many days he will take to complete the race. So a few things happening here. All right, so miles is distance divided by time. Speed equals distance divided by time. Speed, distance, time. And we are working out how many days, so that's time. So time is going to equal to distance divided by speed. So what's my distance here? I'm going to round this. So I can round it to 3,000. Okay, so my distance becomes 3,000. Divided, my speed is 15 miles per day. I'm going to make it 15. I could also do 20 if it was one significant figure. I can do both. If I look at my number, 3,000, I spot 15 goes into 30. So this is how many times does 15 go into 30, if you look at it carefully. 15 goes into 30 twice, then add 2 zeros. Okay, so 200 hours. Okay, for the next race across America, he will cycle for 8 hours per day. So how many days? So my days is going to be 200 divided by 8 hours per day. I can just divide by 2 is 100 divided by 4. And I keep going, divided by 2. 50 divided by 2. 50 divided by 2 is 25. So my answer is 25 days. All right, I hope you got that correct. So you can put it in your answer, 25 days. Part B now. The average speed he can cycle at increases. It is now 16.27 miles per hour. How does this affect your answer to part A? So Juan trains for the race. The average speed increases. It's now that. How does this affect our answer? So if we think about it, imagine going to your school. If it takes you, say, 50 minutes and you're walking there, imagine running there. It will take you less time. So because speed has increased, so speed increases, that means less time taken. So that means that we don't need 25, we need less days. Less days are taken. So here we go to the next question. The marathon is nearly over. I hope you are enjoying today's session. Remember to share this with friends if you are finding this useful. This is from June 2022, paper 3. Change 30 meters per second to kilometers per hour. Press pause and have a go. So we've got 30 meters per second to kilometers per hour. So let's think about what we're doing here on this question. Lot is going on. So I'm going to look at the units here first. 30 meters per second, and we want it to be kilometers per hour. So we've got seconds and hours. So that's what we need to think about. So first of all, in 1 second, we are doing 30 meters. Okay, so I need to look at going to an hour. So 1 hour equals 60 minutes. And remember that the seconds and hours, how many seconds make a minute? So 1 minute equals to 60 seconds. All right, so now 1 second is 30 minutes. So we've got 60 seconds takes a minute. So 1 minute is going to be times by 60, times this by 60 as well. 3 times 6 is 18, add 2 zeros. So this is still in meters. And then to get to 1 hour, timesing it by 60, times this by 60. So we are doing 1800 times by 60 is 108,000. 108,000 meters. Okay, so we've got kilometers per hour. So in 1 hour, we've got that meters. And now we also need to remember 1 kilometer equals to 1,000 meters. So we can just do 108,000 divided by 1,000 equals to 108 kilometers. Let's go to the next question. So well done if you got 108 kilometers per hour. And you can see now the questions are slightly different to what we've had. We are now on question 16 of 17. So we've got A and B, part A and B. I'll do both. Let's zoom in first. All right. So we've got, this is paper 1. So it's a non-calculator paper. You can see paper 1 is from November 2019. Steve drove from his home to his friend's house. He stayed at his friend's house and then drove home. Here is Steve's travel graph. We've got distance from home, time of day. So the distance goes up, goes flat, then it goes down again. For how many minutes did Steve stay at his friend's house? And then part B, what was Steve's average speed on his journey home? So press pause and have a go. When you are ready, press play for the answer. So I am going to highlight key information. How many minutes did Steve stay at his friend's house? So we can see here, this is the flat part of the graph. Let me use a different color. This is the flat part of the graph. And so this is, you can see here, that's 30 minutes. The 45 is the first part. The next part, what was Steve's average speed? So speed, let me write it here. Speed equals distance divided by time. So what is my distance? It's all the way here, that's 25, divided by, what's my time? From 1330 to 1400, that's 30 minutes. 30 minutes, it needs to be in terms of hours, so that's 0.5 hours. Okay, so if you think about how many halves go into 25, we're not dividing by 2, that's a classic mistake. How many halves? So 1 divided by a half. 2 halves go into 1. So the answer to this is 50. The other thing that you can also do is times this by 2 to get 1, and times this by 2 to get 50. 50 divided by 1 is also 50. So that's our answer to part B, 50. And now we are on the last question of today's session. Okay, again, you can see this is a calculator paper, paper 2 from November 2021. And this is also a higher and foundation question. So this is a crossover question. Sam drives his car on a journey. Here is the travel graph for the first 15 minutes of his journey. Work out Sam's speed in kilometers per hour for the first 15 minutes of his journey. That's part A. And then if we go down further, it says part B. At 10:15, Sam stops for 10 minutes and then drives for 20 minutes at a speed of 75 kilometers per hour. On the grid, complete the travel graph for Sam's journey. Work out Sam's speed in kilometers for the first 15 minutes. So for the first 15 minutes, if I look at this, each box is, so here we've got 2 boxes that make 10. That must mean that 1 box is 5 minutes. So this is 5, 10, 15 minutes. So in 15 minutes, we are going to 20 kilometers. We're driving 20 kilometers. And we want to find out the speed. So what is it in 1 hour? So 30 minutes makes it double that, 40 kilometers. And 1 hour, 60 minutes is 1 hour. Double that again is 80 kilometers. So times by 2 and times by 2 again. So we have 80 kilometers per hour. Okay, so we've done that, part A. Well done if you got that right. Part B now. At 10:15, Sam stops for 10 minutes. So we have to put 10 minutes here. So that's going to be, each box is 5 minutes. So that's 5 and 5, that gives me 10. And then drives for 20 minutes at a speed of 75 kilometers per hour. So we need to work out what is that distance. So remember, distance equals to speed times time. That's my formula. So if I think about it, 75 kilometers per hour. So in 1 hour, in 60 minutes, I've got 75 kilometers. And I'm trying to get to 20 minutes. Okay, so what am I doing here? I can just divide by 3. 20, 40, 60. So I'm dividing by 3. I can divide this by 3 as well. Get your calculator out if you're worried about that. 75 divided by 3 gives us 25. So this is 25 kilometers. So in 20 minutes, I'm going 25 kilometers. So from 20, I'm going 25 kilometers. So 5, 10, 15, 20, 25. So it should be here. So that is my answer. And I don't have my ruler handy. Just draw a line connecting them. And that's my answer. So I hope you found today's masterclass helpful. And I really appreciate your time. Hope you've learnt, and see you at the next one, which is probably going to be density mass volume or something like that. Take care, everybody. Bye-bye. Assalamu alaikum.